Hello everybody and welcome to Organian's Puzzle Box. In today's tutorial, I want to expand on my previous tutorial on how to paint on meshes. So in the previous tutorial, which I strongly recommend that you watch and also download the free shader from, we expanded on creating, an intricate system that allows a shader that allows us to paint on meshes, whatever textures we want. And in today's video, I'm going to show you how I've changed that shader to a brand new type of feature, which is using triplanar mapping or world aligned textures in order to allow us to quickly get rid of seams problems from displacement, get rid of hard edges where we might have issues with. I'm going to show you a lot of neat tricks with the modeling tools here, and then you're going to also learn how to use the modeling tools to create a custom shape as well. I've also made this big building that's part of the project. When you download it, you will have access to it, in which I've only used meshes from inside Unreal Engine that I've customly modified, made walls, windows and things like that, and then used this new shader in order to texture this entire building. And it took me actually less than 15 minutes to do the building, which was extremely fast considering I didn't actually model anything. So this tutorial really expands on the previous one, so I strongly recommend that you watch it. Now I'm doing the giveaway again, or basically if you leave a comment in the comment section below, like the video and also subscribe to the channel, you will enter a giveaway. So basically I'm going to spin a wheel and whoever basically gets chosen randomly will win a project from my catalog that you can choose. You can have whatever project you want from all the projects that I offer if you are the winner. So please do that as well to support the channel further. So as shown in the previous tutorial, this is the plane that we used before to create the blends. Now, obviously, I've modified the shader a little bit to encompass a fourth layer, which you can actually see here. So we've got the mud, we've got this concrete, we've got this texture here, which is actually wooden floorboards. And then we also have the blend between the dirt and this cobblestone over here, or concrete, or whatever you want to call it. So I want to show you what the shader changes are, just so you can understand what's been made different. And then we're going to go through these examples that we have here in the scene to further emphasize the usage of this new material shader that I'm going to share with you for free, and how you can use it to effectively build structures with it very easily. And I'm also going to show you a lot of tips and tricks, like I've said, for displacement and for UVing. Like if you check this mesh right here, it's completely bonkers the way it looks, because it has very, very bad UVs. So I've done this on purpose because I want to use Unreal Engine to sort our UVs out, and also I want to use triplanar mapping, so we don't need any UVs at all if we don't want to. So let's analyze the changes by looking at the old shader that we made in the previous tutorial and the new shader that I've created now, or more like I've modified now. In the previous shader, we had three lerps, which were all controlled by the RGB mask. The first lerp was deciding between the concrete and the mud, basically which one shows, and the output of this lerp into the second lerp would then dictate where the blend between the concrete and the mud would show up based on where you would paint the green channel. And then the final lerp was adding back in the concrete base on top of these two lerps in case we wanted to bring back the concrete. But obviously this is kind of a redundant step, because you could just delete this particular blend, which would then make either the concrete or the mud show up again from the previous first lerp. In the new shader, I've made a modification in which we still have the three lerps controlled by the RGB channel, but I have actually added a fourth layer. So now I've renamed everything to layer 1, layer 2, layer 3, layer 4, because obviously we can now use this material for various different surfaces. And layer 4 is just a copy of layer 1 or layer 2 done in the similar style. It just simply gives us the ability to have a new texture. And layer 3 is what we used to have as the blend between the concrete and the mud. So this is the third layer that is effectively a blend between the first two layers. But it could be the blend between any of the layers that you want, really, if you change it. Now, what's important in the new shader here to consider is that the B channel now controls where layer 4 shows up. So if you want to have the base, the layer 1, if you want to have that showing up, which is the first layer that shows up on the mesh when you add the material anyway, you could obviously delete the B channel or the green channel or the red channel, which would then default back to the first layer that we're using in our lerp node system. Now, another change that I've done here, so that's obviously one change in which is replicated for roughness, for normal, and for displacement. So obviously, if you see the previous tutorial, you know exactly how to make this work again. Now, let's have a look at one of the layers as an example to see what other things have changed. So previously, like I've said to you, we had layer 1, layer 2, and this blend, which was layer 3. Now we have layer 1, layer 2, the blend, which is layer 3, and then this other layer, which is layer 4. All of the layer 1, 2, and 4 are identical, but they just use a different naming convention on each of them to basically make sure that we have multiple layers. So obviously this has got the terminology of layer 1, while this over here has the terminology of layer 2. Okay, now some other changes that we've done. Instead of feeding a texture sample straight into our name reroutes to get the base color, normal, and so on, we've now added something else. We added a texture object, which is loading up the texture over here into this slot, and then it's feeding into a texture sample, and it's also feeding into a world aligned texture. And this is going to come into play when we're actually going to be doing a, basically an upgrade to allow for triplanar mapping of our textures. And both of these feed into a static switch parameter. So if we want to use world aligned textures, then this is the node that's going to feed the base color information. If we want to just use a normal UV texture, then this is going to be set to false, which is obviously going to feed this texture sample. Okay, so we've done this for as I said, we've done this for the base color, the normal, and the ORD. Now, very important to note here is that when we've done it for the normal, it used world aligned texture for base color and ORD, but for normal, is using the world aligned normal. Both setups are identical, it just simply uses a different node to make sure that the normal is calculated properly. Now, we're also using a UV tiling system. So we've got our texture coordinates set to false, and a number here of 500 I've put for this, for the scale, as true. So whenever you're using world aligned textures, it's going to multiply this number by the tiling parameter to give us the tiling for the world aligned textures. But whenever we're not using world aligned, we're just using the texture coordinate multiplied by this UV tiling into our texture sample. So this way we can actually use the same nodes for both setups. Otherwise, if we would have put this texture coordinate here into the multiply node, you can see we're getting an error because it doesn't allow us to use a vector 2 information, the UV2, this requires a vector 3 basically for the world aligned texture because it's running in XYZ for the process to work. So I'm just going to make sure that we connect back to how we were, like that, okay? Now, another thing that we've done here is for displacement. So for the ORD channel, or it could be an ARD for you, obviously we're feeding this into a texture sample or in a world aligned texture, and we're using the same static switch parameter here, but at the end of it, we're splitting the components. And this is because I want the green channel to go to roughness, and I want the B channel to go to displacement. I am not using the ambient occlusion for anything in this particular example, but obviously if you want to use it, that's fine. You just need to plug this into the ambient occlusion slot. Everything else has remained virtually the same, including layer 3, which is the blend between layer 1 and layer 2. This is identical as it was in the previous tutorial, and there's no virtual texture needed to be used here because we're already blending between two textures, two layers that are either world aligned or are not, depending on your preference. So every one of these meshes that we have here in the level have their own material instance of the main shader that's being used right here. So the brick, like I've said to you, the layer 1 is the default texture that shows up everywhere. So let's have a look at the material for the cube. So all the material instance parameters are showing up in here, and we have the same options that we used to have from the previous tutorial, but now we also have tiling for each of these layers apart from layer 3, which is just a blend of the first two layers. And then we have a tick box for world aligned, and then all the texture slots that we can put on here. Okay, but looking at this cube, this is the default cube, which is actually dropped from here, from this drop down, okay? Now, as opposed to the plane that we have over here on the floor, which has displacement, this cube does not. And there is no real way to enable displacement on this, regardless of what we do. So we can obviously press this displacement intensity to whatever value we want, but that's not going to do anything because displacement is not fully enabled for this particular cube, even though it's enabled in the shader. because this is not a nanite mesh. So we want to make this into a nanite mesh, but unfortunately it's using the default cube and we don't want to change that. So if we actually search for it, you'll see that it's in the engine content. Now here's what we're going to do. We're actually going to make a copy of this cube. So we can right click it and copy, and then we can go into our content browser, wherever we have our project, okay? And then we can go in here, for example, and I can Control V to paste the cube over like that. Now this cube, I can drag it into this slot, and then I can also double click it to open the cube, which will allow me to enable nanite support and then press apply changes. Now if we have a look, we do have a displaced cube, which looks horrible because the displacement isn't properly showing on this mesh in the state that it's currently at. For example, there isn't a lot of geometry and there's no chamfering on the edges either. Now, you can obviously modify the material instance to try and fix some of this stuff, like for example, reducing the displacement, but this is not going to give you the results that you want. It's just definitely not going to, you know, effectively work the way you imagine it would work. So here's where the world align texture comes into play. I'm just going to tick the box just so you can see, but I'm going to explain this further in a bit about the setup that you're going to do for world aligned. So I'm just going to basically tick all these boxes for all the free layers. And as you can see, world aligning has allowed us to fix some of these issues, even though the tiling is now completely different. So I might want to, I want to change the tiling maybe to a value of 1 here. And the reason why you want to do it, obviously for all 3 layers, is because if you're going to paint any other layer in here, then you're going to want to have similar tiling. But we could we could obviously change this to like a 0.5 to get even better tiling. And now we can see just the change of their world align didn't do much to fix any of this stuff actually. So what we're going to do now is we're going to edit the actual mesh itself. So before we talk about world aligning itself, we're going to look at how to fix the mesh first. So we're going to go into selection mode here and we're going to go to modeling. Now, if for some reason you don't have modeling enabled, which I find that to be impossible considering that you have mesh paint enabled, you can always search for I think it's modeling. There we go. So modeling plugin. So enable the modeling tools editor mode. This is what you need in order to start modeling your meshes. You can also enable this one here, modeling mode, if you want, but this is the one that we need for this particular example. So I'm just going to go into modeling mode, and with my cube selected here, I can actually go to voxel and then do a voxel wrap. And you can see that it's now going to add these chamfered edges, which is going to help a lot with displacement. I'm going to click accept, but what you don't realize is that now we no longer are using the cube that we just made earlier. Instead, if we go into our content browser, you notice that the cube is still here unchanged in any particular way. But if we go into our map folder, so wherever this map that we have opened is opened, we can see that a new folder has popped up called generated. And if we open this and we go in here, we will find the cube that now represents this cube over here in the world. So I can double click this one, and then I can enable nanite support and apply changes. Now, when I do this and I go back into the level, you'll notice that I can now put in the material slot that we were using. So I'm just going to search for it very quickly here. And I am going to drop the cube material like that. And now you can see that we no longer have those very bad edges onto the cube, okay? So this is basically working the way we intend because we're now kind of fixing this problem. But there is another problem that we've now built in, which is if we click on this new cube that we've created, this one here, you'll notice that its vertex, this nanite triangles, is completely off the charts. So we need to simplify this mesh because it's way too complex for what we're trying to do. So I'm going to keep, selected again in the modeling tools. I am going to go over here to the mesh tab. And in here we have an option to either remesh or simplify. So in my case, I'm just going to simplify it. And I do want to simplify it by about, to 10%. So target percentage, about 10% of its original vertices. So I'm going to press accept, and this will obviously change the mesh now to a new vertex count. And if I go over to the cube, you can see that it's now been toned down to 19,000. But guess what? You can actually keep doing this. So I'm now doing it yet again to 10% like I did before. And now if we go over here like that, it's now 1,900, Obviously, you can do this as many times as you want, but there will be a point in which the mesh starts to suffer. Now, there are going to be some other caveats, which I'm not really sure if it's visible. I'm just moving around to see if there is, but no, there isn't any visible caveats for this particular mesh. But normally, you might get some normal issues on it. So in order to fix them, like you can see here, we have a split like that. If you want to fix normal problems, then you want to go over into the attributes over here, and then click on normals, and then just press accept. You don't really need to change any other settings in here, just press accept. And this is now fixed the normal issue, and including that line that you saw here. So all the normals are now facing, smoothed properly across the mesh as it should. Okay, now let's move on to the next thing, which is painting it. So if we go over to mesh paint, like I showed you in the previous tutorial, and we go to texture color, we can press the add button, and now we can paint with either red, green, or blue. So let's paint with blue. So I'm just going to try and paint over here. So I'm going to change the size of this brush, and I'm just going to try to paint, and look at that. It's so beautiful. It's so beautiful that nothing is actually happening. So what the hell is going on? I can try another layer, so maybe the red channel. This doesn't seem to paint either. So there's clearly a problem here that we need to address. So the problem that we have lies with the UV of the mesh. So if we actually open the cube over here and we go to UV channel, you'll notice that it's actually not an UV at all because we remeshed it. And if we go to the original cube and we check its UV channel, the UVs are wrong anyway, because you've got all the, got all these faces overlapping into this bit, which is again not going to work out because you paint this face and this will, well, you paint this one and then the other opposite one will be painted as well. So that's not going to work out properly either. So what we're going to do, we're going to go back into our modeling here. We're going to select UVs. And in the UV, I'm just going to auto UV because this is a very simple cube. Auto UVing is easy, and you can kind of see the result of what the auto UV is going to do by checking by making sure that you've got this tick box here enabled, and it shows you what it will do. Obviously, you can unwrap your own mesh if you want. One of the points of these bricks, by the way, showing up in here onto this cube. The only reason why they're showing up when the UV is obviously got issues is because we're using triplanar, which is world aligned, right? But if we would disable world aligned, look at that. The cube looks like a mess. Nothing in it makes sense because there's no UV for it. So triplanar projection allows you to bypass the UV requirement, but that doesn't actually mean that mesh painting will work because it needs a UV, as we know from the previous tutorial. So I'm going to press the auto UV and then press accept, and all of a sudden now we have a new UV. We can go over into our mesh paint, and we're going to go to paint mode, and now look at that. Beautiful, right? We can now add, so the green channel is the blend between the bricks and layer 2, right, which is the damaged bricks. Okay, now if you get like these artifacts, like shadow artifacts and whatever, this is a known thing with nanite displacement for now when you're in the viewport, but hopefully they'll fix this more in the future. Now in the material here, we can obviously play around with the contrast of this change, and we can also play around with the transition phase. So if we want more of the bricks to show up or less of them, we obviously can just play around with this transition or the contrast. So I think I'm going to do maybe something like that, and with a high contrast. I think that looks quite nice. Okay, and I'm going to go back into our mesh paint, and I want to also add, let's see the red channel, what it does. So this is going to bring in just the damaged bricks without any kind of blend. So there we go. And then the blue channel is going to bring an entirely different texture, which to make sure the strength is set to 100 so you can see the change. But one thing now is also using very low resolution painting. So we need to fix this. With the cube selected, this cube, we can go over here to override the mesh paint resolution. I'm going to put that to 256, and I'm going to press the fix button over here to fix that painting. And now it looks a lot better, as you can see. So it's very important that you set the right resolution for painting in order to get the expected result. Now here's the thing. We can obviously paint on any surface that we want, and for example I can go in here and paint even this top layer like that. But obviously wherever you have edges like what we do here, there's always going to be some issues. So I would definitely try and put an edge that makes sense, a structure or a you know, a texture that kind of makes sense for edges, like bricks. And also you could probably want to increase the poly count of the mesh in order to get a better result. Now I'm gonna change this maybe to a blue over here and try to add some more contrast, more, you know, more painting like that. So now I'm using damaged bricks here on the top in combination with the normal bricks over there. And every one of these layers is independently controlled by, you know, through tiling. By the way, you can see the resolution of the viewport improves when you get out of mesh paint mode, but you can always sort of like go over here and change your screen percentage to 100% to get a better resolution when editing. Obviously, this affects performance if you're not careful. So we could play around with the tiling here, as you can see. So obviously, we could change this. So I think 0.3 for that looks just fine. So that's what we did for the cube. Now let's have a look at the triplanar setup so you understand what that does before moving on to the rest of the tutorial. So I want to emphasize the world aligned texture setup, or triplanar basically. I want you to understand just kind of how it works. So we're using a texture object, not a texture sample, to effectively feed the texture through these two nodes, either for a normal texture or for a texture or for a normal. So this works for base color and roughness, ambient occlusion, and so on. I've actually seemed to have done a mistake here, which is fine. Obviously, this wouldn't connect to this one. This would just simply output a normal here, right? So we could like say this is a test normal. And this one could be used twice, once for the base color, and a second time it could also be used for the ORD. So for example, it could give us the RGB like that we can then use for ambient occlusion, roughness and displacement, or whatever other maps you have. We obviously have a tiling in here. You don't need to feed anything else into these parameters apart from these, you know, the tiling and these textures, because everything else is kind of, you know, it's not that important. But if you really want high quality normals, for example, so less mipped normals for your output, you can always add a static boolean here, and you can plug this over like that. And obviously, if you tick this, you will get high quality normals, and if you untake it, you will not get high quality normals. That's everything you need to know basically to plug in and get the result of world aligned. And you'll know that it's working because if you have a look at your mesh that is, you know, it's got world aligned textures enabled. Well, first of all, the textures are being projected from all axes, and if you rotate it, you'll notice that these textures kind of stay in place while the mesh is rotating, right? So that's kind of a very good observation to understand why, you know, if it's working or not. And also, if you look at this pillar that doesn't have any UVs over here, it's the same thing. Like if I'm going to bring the material for the pillar and I then enable world aligned textures, you'll notice that it works just fine. We are now obviously getting this result. So let's now explore another caveat that you're going to have with these type of meshes, especially whenever you're changing their size. So if we look at this cube, which is using the default cube right here, we're going to change over to the cube that we copied earlier, the one that we made a duplication of. So we're going to use that new cube. And when we drag it in, obviously we'll now have displacement, but it doesn't have any of the fixes of the cube underneath here. But this is not the purpose of what I'm, you know, trying to show you here. What I'm trying to show you is that if we duplicate this cube and then we set this up to a size of 2, now, our textures have not changed in any meaningful way because they are triplanar. But what happens if we disable that? So if we go over here and we disable triplanar for this, you'll now notice that obviously the tiling on this is larger than, well, not larger, but the entire texture on this is obviously bigger now because the cube is also bigger. But this cube has got a scale of 2, while this one has a scale of 1. So we can actually try and bake the transform so that this becomes the new scale of 1 for this cube. So if we go over into, you know, like modeling in here, just bear in mind that when you do go over to Xform and now bake the transform, it will actually bake the rotation and scale of this mesh, but to the static mesh that it's being generated from. It's not going to just do it to this particular one. So if we select bake transform and then press accept, oh, sorry, let me just select that and press accept, you'll now notice that this other cube over here has now been changed to this size of this one. And that's what happens when you as I said, when you bake the transforms. So this is an important thing for you to understand, because ultimately this is going to, like, you know, after we've made these changes, even the displacement has changed. Okay, so if we switch back to the scale of 0.5, which is the scale that we had previously. Okay, so you can see the displacement looks like this now onto this mesh, onto this new scale. But now that we've put it down and we're going to bake the transform again and press accept, now you can see that the displacement has also changed. And this is predominantly because of how big the texture was magnified onto the cube when it was bigger. And then obviously we normalize it by baking its transform. So scalability plays a major role. The scale of a mesh plays a major role in how displacement is being handled. So be careful with that. Because when we look at this pillar over here, okay, this column, this has got the same sort of issue. The scale is very big for a scale of 1. So maybe I want to make this smaller, like a 0.5, like that. Okay, now right now it doesn't have any displacement on, and it doesn't have any of the fixes that we did previously. So I'm just going to open its material and bring it over here. Obviously it's got world aligned enabled, which is great, but I am now going to bake its transform. So I'm going to press accept, and I'm also actually displacement is enabled, sorry. You can see it there, and now it's actually making a lot more sense in the tiling of how it sort of like looks. But let's do this. Let's fix this particular mesh with the previous method that I showed you, which was over here into our voxels. So we'll do a voxel wrap. We're going to press accept. Obviously it's created some problems over there, so you might want to have a look at doing some you know, going over into the mesh in here, and you might want to remesh it, you know, something like that. And obviously you have a lot of options in here, like smoothing, so we could probably do a higher smoothing rate, like something like that, you know what I mean? Obviously this means that we've also lost that edge. So if we undo most of what we've done, we did have this edge over here that when we did the voxel wrap, it made it disappear. So this is why you want to increase your voxel count in order to make sure that you're getting, you know, your mesh kind of stays there. So when you press, oh, sorry, not cancel. When we press accept, which for some reason, yeah, there we go. When we press accept, now we have a higher resolution of that. But obviously this means that the number of nanite vertices that have been created, or vertices in general, has increased quite a lot, because we're obviously, you know, well, we just use a very, very high level of subdivision. And as you can see, the engine is also taking its sweet time to do this. So now we have it done, but it's way too much. So at this point, we would want to go over into model, sorry, not model, we want to go into mesh, and then we do want to simplify it. But because again, this is a very large mesh, even the simplification will take a bit of time for Unreal Engine to kind of work it out. And again, 10% might just be great. You will have to wait for it to process it before you can press accept. So depending on how fast your computer is, you may want to do this in a different program than do it here. But the idea would be that we are trying to get an edge that's chamfered, beveled, whatever you want to call it, to help displacement to properly show up in here. I'm just showing you a method to do this that's in engine, and that predominantly is quite fast if you're not going for massive voxel counts. Obviously we wanted to preserve this edge over here, which is adding more complexity. And as you can see, this is actually taking quite a bit of time here, you know, to actually get the result that we want. So I'm just going to skip to the point where, you know, it's done so we can proceed. So now we've simplified it, and we obviously have quite a bit of issues here and there. So what we can do is obviously go over to attributes, go over to, attributes, and go over to normal, and then we can press accept. I'm going to make sure that the normal calculation, obviously you may want to change this to various different other options in here, depending on what you're trying to calculate, but I think this one will be fine. Something like that, okay? But we don't really know how good it's going to work until we actually apply it to the material. So I'm just going to search for the material and just drag it in onto the mesh like that. But we do want to enable our, nanite support over here. So I'm going to apply the changes and then see what kind of result we're getting. We obviously can simplify this further, but as you can see, what issues we had previously are now gone, which is amazing. But there's another thing as well. Do we want to UV unwrap this? Because right now it's not going to work without triplanar projection. So just make sure that you're aware of this. So again, we can go to UVs over here, and we can select auto UV. You can then see a preview of what that looks like, something like that, okay? Which actually kind of makes more sense now. So we can press accept. Again, this is not going to be a very clean solution. This is an automatic solution, but it hasn't changed much from what we gathered, what we did. But you're going to be looking at these tiling over here and you're thinking, well, those bricks might not make a lot of sense. And this is where I think you can obviously use painting to fix that in however way you want. But I am now going to show you a use case on the sphere of what triplanar can do for you to kind of understand how texture stretching will be resolved. This obviously applies to the cylinder here as well. And also we're going to then look at this archway, how I made it, and also how we can resolve texture stretching to make it look like what you're seeing here. So let's go over to the sphere so I can show you my example. So considering this is the Unreal Engine default sphere, it's already UV unwrapped, but if we remove this sphere from the top, you'll notice that it's got texture stretching right here, okay? That's where the points, the vertices are all combining into one single point. Now, with the material of the sphere, if I bring it over here for you to see, we can see we have no world align textures enabled. And all the bricks are following this pattern around and around the sphere. But if we enable world aligned, all of a sudden, what we're seeing is that the pattern changes. So let's just switch over to a smaller tiling so we can see. Maybe even smaller than that, 0.5 generally works quite well. Oops, sorry. There we go. And obviously I can change, we don't need to change for everything necessarily because only layer 1 is being displayed. But you can kind of see there how the tiling for these bricks are being handled. This is the top, this is one of the sides, and this is the other side here, okay? Now if we go over into mesh paint and we want to paint this one, so I'm going to add, switch to paint, and let's say I want to paint the red channel over there. Again, you're not really seeing any painting happening. And this is because we have the same problem as before. The UVs are not properly displayed. And also, not to mention, the resolution of the paint is not that great. So we could obviously change this to 256, press fix, and still doesn't work. So we could try any other channel, and again, it will not work properly. Even though if we switch over to the RGB channel, you can see that we have made some painting. So again, this is important that we go into modeling and we have a look into UVs. Obviously, this won't allow you to do this, to change it, because this is a engine asset, which is why I showed you that trick. You can copy the sphere, go into your content browser somewhere, wherever you prefer, paste the sphere, and then replace it, okay? And then obviously with the sphere open, you can also enable nanite tessellation, which is great. And then we can auto UV unwrap and press accept, which should allow us now to mesh paint, which is, again, kind of hopefully the effect that we wanted. Now you'll notice in here that I am doing mesh painting and not a lot is going on. So why exactly is this not working? As you can see, when I kind of do it this way, it does start to show up. And even though we have the resolution in here and everything is fine, it's still not painting properly. So in order to debug this, if we go over into the sphere, we'll notice that we generally always have this, 2 UV channels for every mesh. So this is the UV channel, this is the UV that's been generated earlier through our auto unwrap. And this is another UV channel that's also been done automatically, but there's a lot of overlap here. So if we switch back to UV channel of 0, that's fine. We can go over into our mesh paint and we can have a look here where we set up the mesh paint and make sure that our texture sample is looking at 0 instead of 1 for the UV sampler there. And once we do this, the mesh paint will be added to UV 0 instead of UV 1. And in theory, it should have fixed our problem for the sphere. So I'm going to go back in here, and as you can see, it has indeed fixed it. So I'm just going to, sorry, it's decided to auto save all of a sudden because that's what Unreal Engine does on its own, by its own volition. Right, so I'm just going to go into paint mode here and going to try and use this. maybe get rid of all of this blue. So I painted a lot of blue around here, and as you can see now, it's working like a charm. Okay, so I can add any texture that I want anywhere that I want, as you can see, which is great. Okay, so that's about the sphere that I wanted to show you. Now the cylinder is got like the same kind of similar thing style here. So if you open the cylinder, what I would advise you to do is obviously use world aligned, which automatically fixes most of your problems. Okay, just set the scaling properly to what you want, and as you can see, this already fixes it. But you would want to repeat the process that we did for this or for the cube in order to get proper displacement on it. But now to the archway, because I want to show you something interesting. How to make this archway out of a cube in order for you to kind of get an idea of what's the best way to start constructing, for example, buildings using this particular shader. Okay, so for this particular example, we're just going to take one of these random cubes. It's fine. I'm just gonna, bring it over here. Hopefully I can bring it also to the surface. Okay, there we go. And it doesn't matter the material. I'm just gonna leave that for now, but we have this cube as a starting point. And we have to also take note that the pivot point is in the center of the cube, which is very important, and it's got a scale of 1. Okay, so the first thing I want to do is I want to scale it up like that, on the on this axis. Maybe bring it a bit higher here. And I'm not going to, I could obviously scale it this way, I could scale it that way, but it doesn't really matter. I can just keep it like that to have a squared shape. The next thing I want to do is I want to change its pivot point. So what I'm going to do over into modeling, I'm going to select X form, and I'm going to click the edit pivot point and then bring that pivot point all the way down here and press accept. Now the next thing I want to do is go over into our deform, select warp, and as you can see, when it's warping, well, we're not really getting a very good result because the resolution of the cube is too small. So we can actually go over into our mesh and remesh this, so we can effectively add more triangle count. So maybe 5,000 would be quite nice. I'm going to press accept, and then I'm going to go back into deform, select warp, and as you can see, it's warping quite nicely. The problem with this warp is that it starts from the base, so we can have a look at the lower bound to go up. So maybe we want to start this at -50. Okay, and then obviously it ends over here. So we can now press accept, and we can then go again into here, not deform. We can go, let me just make sure, into not mesh, sorry, into model, and then we can select mirror, and then I can select the option that where I want to mirror from. So for example, the right, which now creates an arch like what you're seeing over there. And obviously I can move this across if I want the mirror to start somewhere else. Oh, sorry about that. Let me just click mirror again and make sure that I'm using the right setup. And I'm going to press accept. And now we have a mirror, as you can see, which is really, really nice. Now the pivot point, we would probably want to center that. So we can go again to X form, edit pivot point, and then just move this over somewhere around there. Or, you can obviously eyeball it or whatever to make sure that it's in the center of the mesh, but like that is fine. Now, our UVs are completely messed up, and even though the mesh cube obviously is not using triplanar, we can enable triplanar, but we're still getting this stretching right here because this is the point of the triplanar map switching from X and Y to the Z axis, okay? And as you can see on this other mesh over here, we don't really seem to have that stretching issue like we have over there. And this is, if I take that material, just for argument's sake, I'm just going to take this archway material and I'm going to drop it over here. It still hasn't fixed anything, and if we open it, we will notice that there is no triplanar enabled either. So what's the deal? Well, we need to sort out the UVs. So we're going to go over into the UV map in here, and we have a bunch of options that we can use to fix this, but it's not going to be the auto UV like you were looking at, because if I click auto UV, you'll notice we're still going to have a lot of issues with it. So if I press accept, hasn't really fixed anything, right? It actually made it worse. So we've got to fix this in a way that actually makes sense. So for me, the best way to fix this in this particular shape would be to use a project UV function. Now, when you choose projection, you have a projection type. So you can obviously select from plane, cylinder, even this example map here, whatever that stands for. But for me, I'm actually going to use box for this one. And then the dimensions is where the trick lies. So you want to play around with dimensions and just try to kind of eyeball this until you get nice squares, as nice as you can get them. You're never going to get this perfection, right? You just got to make sure that you're hitting as much of this as possible to look as square as possible. There'll still be some stretching here and there, but as I said to you, you can mitigate a lot of this stretching by just eyeballing and making sure that you're kind of hitting a point where it looks rather nice. So I think this might be it. So I'm just going to press accept. And I think that's kind of it here. Now what we can do is, obviously we've got displacement enable, so I can turn that down to like a 0, okay? So when you turn the displacement down and then you have a look at the UVs itself, maybe something like a 4 or 5 or something like that, you can see that it's actually quite good. But then if we turn displacement on to maybe like a 5 or something, it's not going to be great how the displacement is showing, because we still have issues with the borders. So again, and these are facing upwards. We can obviously go over to attributes and go to normal and press accept, which might help a little bit, but it's still, the orientation is not amazing. It's still kind of squished forward. But we need to add more geometry to this to make it work better. So again, we can use the voxel here to wrap. And obviously this count is way too big, so we might want to get to like a 20, well, not a 25, sorry. Maybe. So I'm just having a look here. What would be, yeah, maybe something like that. And then I can press accept. Obviously this is going to work quite quickly. Then we go over into mesh and we can have a look at either simplifying or remodeling, or even going to have a look at, see if we can smooth it out as well. But that might not be, you know, that might not be necessary as much as you think. So I'm just going to, you know, decrease it. And now that I've created it this way, I can drop the new material on it. And obviously I want to unwrap it. So if you do auto UV, you're going to have the same issue as before. So you want to do the project UVs. And again, just kind of make sure that it's all setting up. Maybe something like that. We're going to press accept. And we also want to go over into attributes and make sure that our normals are set up correctly. And now we can have a look at playing around with the displacement. Obviously, right now it's set to, well, actually set to nothing because the displacement is not running through the mesh. We just need to enable nanite. And you can have it something like that. Obviously, this is still, there's like holes in it. So you may want to remesh this and add a bit more geometry to make it so that it fills those gaps. But you also can play around with the displacement itself, because you know, a number of 5 is sorry, a 10 is really high as well. So you may want to do that and then play around with the displacement offset so you can bring that in a bit more. So displacement offset will allow you to sink in the there you go, something like that. Okay, and now I've taken the liberty to create a building using only these meshes here. So, you know, this pillar, this column, these cubes and whatnot, just to create something resembling some form of a church. Obviously, this needs a lot more work, but as you can see, this is the power of this sort of tiling method with world aligned textures. And we can use mesh painting across all the board. Like, for example, I know these are obviously individual meshes over here, but let me show you something. Let's just take this roof as an example. And let's just say I want to paint all of it, because I could paint a singular one. So for example, I could go into paint mode right there, and now I'm just painting this one. But I could also go to select and actually select all of them, and then go into paint mode. And now look at that, I can actually paint across, and obviously each of these is individually controlled, but I can paint multiple ones at the same time. So that's a very neat trick, and it allows you to quickly iterate through all of this, right? Because you can see in here, I can add a lot more variation, a lot more textures across very quickly. So this is going to help me to further develop this process, because again, once you've placed your meshes in however fashion you wanted, you can obviously just go in with this mesh paint system and just quickly fill in the blanks. And it's a very powerful tool. Just make sure that you're using the a nice resolution here, so your base mesh would predominantly should be already set to that resolution before you actually start duplicating it all over the place. Otherwise, you'll have to do it for each of them, which is not fun ever. But as you can see, that's just how powerful it is. And obviously, this entire thing is found within the project. So I'm just going to move over here into the scene. So I'm going to walk with my character into this building. I've got some fake lights here to add more sort of dramatic effect into the inside this building. And yeah, as you can see, the building itself, inside it's not painted in any particular way because I haven't done it, but I'm obviously can refine this quite quickly by selecting multiple meshes in here and just playing around with the mesh paint feature. So I can go back into mesh painting. Obviously, it does need you to select everything while you're inside of it, otherwise it won't work. I can go into paint, and now I can start adding some interesting sort of shapes and textures in here. And obviously I could overwrite any of these textures with something else if I so choosing, if I so choose. So it's really up to us what we want to do. So it's really, I mean, it's really powerful, and there's a lot to do. Like, there's a lot to refine and improve onto the blend and onto the shader as well. And there's also a sale on Fab going on right now for a couple of days, where 3 of my projects are 50% off. So that's the World Forge, the Cloud Forge, and the Asteroid Ring Library. All of these 3 are very powerful tools that you can actually even use together to create space scenes or massive worlds as well. So please feel free to have a look at that. The link is in the description below. But let's not delay any further.